Hey, seventh graders. I hope everyone's doing well. Instead of having a Zoom meeting, this might be a little long, so I thought I would just go ahead and pre-record it for you so you can watch it whenever you want to. So let's look at some transformations. So there's four different transformations. They are translations, reflections, and rotations. The other type of transformation is dilation. That one's a little different because the first three that I mentioned, translations, rotations, and reflections, once you do those transformations, you get a congruent figure to your original. And then dilations, you create a similar figure to your original. All right, so the first thing we're going to look at is translations. So first of all, just a quick review over the coordinate plane. So that center right in the center, or that center in the center, that point right in the middle is called the origin. So the coordinates of the origin is always 0, 0. So right there in the center between the X and Y axes. And that's where you start. Every time you're going to graph a point, you always start right here in the middle. The horizontal axis is the X axis, and the vertical axis is called the Y axis. So for all coordinate planes, you have 4 quadrants, and you always start up here in the quadrant 1. And to get into quadrant 1, you need 2 positive numbers. So you'd start at the origin, you would go right and then up. And then normally we're used to counting things clockwise, but the quadrants actually are in counterclockwise rotation. So we have 1 and then 2. So to get in the second quadrant over here, we would go from the origin left and then up. So a negative followed by a positive. Get into quadrant 3, it would take 2 negative numbers. You start at the origin and go left and then down. And then finally quadrant 4, to get over here, you'd start at the origin, you would have to go right and down. So then you would need a positive number followed by a negative number to get into quadrant 4. So in geometry, a transformation changes the position, shape, or size of a figure on a coordinate plane. The pre-image is the original figure. The image is the resulting figure that was changed or moved. So if you look at the notation up here, this first triangle is the original, it's the pre-image. The reason I know that is because of these little marks. It looks kind of like an apostrophe, but this indicates, these marks indicates that that's the image. So you would say that this is triangle ABC. This is triangle A prime, B prime, C prime. All right, so that's how we know which is the image, is which one has those little marks called the prime marks. It is common practice to name shapes using capital letters. So that would be square A, B, C, D. It is common practice to name transformed shapes using the same letters with a prime symbol, A prime, B prime, C prime, D prime. So the types of congruent transformations, so if we're going to change the location or position of a shape, we're going to create a congruent figure. So that would be when we make the transformations, which is a translation, reflection, and rotation. And congruent figures have the same shape, same size, same lines, same angles, same everything. Just they've been moved. So just like you're skating, if you're sliding across the ice, you are translating. When you are translating a figure, you go right or left. That means you're going to adjust the X value. And when you go up or down on a coordinate plane, that means you are adjusting the Y value. The new image is congruent to the pre-image. All right, so here we go. So on this first example right here, we have a triangle down here, and it tells us that we're going to translate this triangle 4 units to the left. So we're going to take each of the vertices, each of the points, and we're going to go straight to the left. 1, 2, 3, 4. Wait, did I count that right? 1, 2, 3, 4 positions. This one is 1, 2, 3, 4. My pen hates little round dots. And then 1, 2, 3, 4. So when we're done, if I could draw a straight line, which is nearly impossible for me, just pretend those are good straight lines. So basically my image is congruent to my original. So if this was angle A, I would label this A prime. Same thing here, B, B prime, C, and C prime. All right, here's another triangle. We're gonna go straight down 7 units. So each of the 3 points, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And straight down 1, 2, 3, 4, 5, 6, 7. So when I'm finished, if I drew a straight line, oh my goodness, I turned my pen off. Did it? Yeah, it did. If I drew a straight line, oh my goodness, what happened? Did I mess the whole thing up? No, there is. Okay. Anyway, something like that. And then here we have well, it's one translation, but 2 different directions. So we're gonna go left and then down. So we're gonna go left 2, 1, 2, down, 1, 2, 3, 4. This one we're gonna left 2, 1, 2, 1, 2, 3, 4. Here we go left 2, 1, 2, 1, 2, 3, 4. So no matter what we're translating, whether it be a triangle, a square, a rectangle, whatever it is, even if it were a straight line like this, if I could draw a straight line, if I translate this, wherever it ends up on the coordinate plane, it is congruent to the original. Same shape, same size. And triangles have the exact same angle measurements. All right, so more of translating. On this one, we do 2 things. We go right and then up. This one is straight up 3 units. And this one, we're gonna go right 5, 3 down. I'll only do the last one just to save a little bit of time because it's the same thing over and over and you don't really have this in front of you, so you can't really do it on your own. And it's not a lot of fun watching someone else translate. So anyway, we're gonna go 5 right, 1, 2, 3, 4, 5, 3 down, 1, 2, 3. Stop it. 5 right, 1, 2, 3, 4, 5, 1, 2, 3. Oh, I don't know why my pen hates those little marks, but it does. And then we're gonna go 1, 2, 3, 4, 5, 1, 2, 3. And then the last one is gonna be here and my dots won't stay, but that's it. Alrighty, so basically that is translations. You're just going right, left. The original is the same exact coordinates as the image. Now, I do want to talk to you about the rule. So if you are going to go right on a coordinate plane, what kind of number makes you go right on a coordinate plane? A positive. So if you're going to move a figure to the right, you are going to increase your x value, the first number in your coordinates. If you're going to go left on a coordinate plane, that takes a negative number. So you are going to decrease your x coordinates. Same thing going up and down on the y-axis. In order to go up on a coordinate plane, you're going to increase your y-axis or y values. And to go down on a coordinate plane, you're going to decrease your y-axis or y values. So for example, here we have our original A at -1, 1. So from the origin, we go left 1, up 1. So to go to A prime, we can figure out what our new coordinates are going to be just by doing the math. So basically, this tells me that whatever x was, we're going to add 3 to it, which means we're going to go right on a coordinate plane. And then whatever my y value was, I'm going to increase it by 5, which means I'm going to go right 3, up 5. So if I start at my x coordinate at -1, -1 plus 3 is +2. I started at +1 on the y-axis, and I'm going to go up 5. So 1 plus 5 is 6. So A prime's coordinates should be 2, 6 when I'm finished. All right, what about B prime? Well, x was at 5. I'm going to go right. 5 plus 3 is 8. and y was at 4, so 4 plus 5 is now going to be on 9. And then C prime, the original C is up here at 4. Oh, no, over here it's 4, -1, so this is C. 4, -1, so if I start at 4 and I go right 3, I'm going to end up being at +7. I was at -1, but I'm going to go up 5. -1 plus 5 is 4. So once we do these transformations, right 3 up 5, this is exactly where we should land. So -1, so I'm sorry, A was at -1, 1. So if we went right 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5, we are at 2, 6, just like we thought we would be. So this is A prime. And then C, I'm going to go right 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. So now there's C prime, which is at 7, 4, just like I thought. And then B prime would be the same thing. I would go from here, right 3, 1, 2, 3, 1, 2, 3, 4, 5. And I land up here, ooh, at what? 8, 9, 8, 9. Okay, so that's how the rules work for transformations. All right, I'm going to go through the rest of these. I'm going to get to translations. All right, so let's look at, I'll do reflections first. All right, so reflections just means that you're flipping a figure across something, either across the x-axis, the y-axis, something. So reflection across the x-axis, basically that x-coordinate is going to stay the same, but the y-coordinate is going to become the opposite sign. So reflect across the x stays the same and the y changes signs. So what does that mean? So here's our x-coordinate, right? Our x-axis is right here. X-coordinate is right there. So if I'm going to reflect that, I'm going to flip that figure over that x-axis. So it's going to go from here, I'm going to flip it over the x-axis, it's going to land down here. So see how A is 2 units above the x-axis? I'm going to flip A over that x-axis, is going to be 2 spots below the x-axis. So that's going to be A prime. Y is 1 space above the x-axis. You're going to go toward that line of reflection and keep going 1 space below. So this is, oh my goodness. This aggravates me. Stop it. All right, so Y was 1 above, we're going to go 1 below. And then E is 1, 2, 3, 4 above. We're going to go straight toward that line of reflection. 1, 2, 3, 4. We're going to keep going. 1, 2, 3, 4. And there's E prime. And then my Y prime should have been right there. And I can't draw straight lines, but you guys already know that. And so if they were straight, they would be a congruent figure. All right, same thing with this 1, 2, 3 quadrilateral over here. If we're going to flip it over the x-axis. So G was 1 above, it's going to be 1 below. 1 below. C is 1, 2, 3 above. We're going to go 1, 2, 3 below. 4. T is 4 above. We're going to do 4 below. And Q was 5, 4 above. We're going to do 4 below. And that is our congruent figure, sort of. And so that's how you reflect. So if I went across that x-axis, I'm going to go straight toward that line of reflection. 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So if I write out those coordinates, I see that the x-coordinate does not change, but the y-coordinate becomes the opposite. the opposite side. Well, the opposite thing is going to happen when you reflect over the y-axis. This time, the y-coordinate stays the same, and the x-coordinate changes sign. So whatever x was, the x changes the sign, and the y value stays the same. So here we want to reflect over the y-axis. So here's that y-axis right here. So we reflect it. We're going to flip it across it. So this time we're going to go toward the line of reflection, which is the y-axis. So L was 1 right of. L prime is going to be 1 left of. G is 1, 2, 3 to the right of. We're going to go 1, 2, 3 to the left of. And Q is 1, 2, 3, 4 to the right of. We're going to go 1, 2, 3, 4 to the left of. So we're going to go from here to here to here. All righty. All right, and so you would do the same thing with any figure. Whatever that line of reflection is, you count toward that line, and then you keep going in the opposite direction. All right, so I'm going to reflect it across the y. So a lot of people think, oh, I'm going to flip this thing down here, but nope, that's the x-axis. You got to find your y-axis or whatever your line of reflection is, and think about how am I going to flip it over that line. So I'm 1 to the right of, I'm going to be 1 to the left of. I am 5 to the right of, I'm going to be 5 to the left of. 2, 2, and then this is 4 and 4. So all right, so we have this, we're going to have this congruent figure when we're done. Oops. Oh my goodness. All right, make sure you realize they are congruent. All right, so that's reflection. Now, what is the line of reflection? Well, what's our original figure here? Was the black one, because the red has the prime marks. And this has been flipped from here up here across the what? The line of reflection is the x-axis. All right, what about this one, which is our original? The original is the blue one because the red one has the prime marks. So this has been flipped from here over here. They're congruent, same shape, same size. And the line of reflection is the y-axis. All right. Good deal. All right, one more set of problems we're going to look at, and these are rotations. All right, so when you rotate, that just means basically you're going to turn a figure around. Usually in this class, it's going to be the origin, okay? So let's see what it has to say. So when you are going to rotate 90 degrees, so there's several different ways you can rotate. You can rotate it based on the number of degrees and which direction are you going. Are you going clockwise or are you going counterclockwise? So if you go, you can go 90 degrees clockwise, you can go 90 degrees counterclockwise, you can go 180. Will it matter if you're turning it upside down? Would it matter which direction? No, it doesn't matter which direction when you're going to rotate 180 degrees. And then what about 3 turns? 3 turns is 270 degrees clockwise. Wouldn't that be the same as 90 degrees counterclockwise? It is. They're the same. So 270 degrees clockwise is the same as 90 degrees counterclockwise, and 270 counterclockwise is the same as 90 degrees clockwise. So let's look at, okay, that's just what I said just then. 90 degrees clockwise is the same as 270 counterclockwise, and number 2 is a similar statement. So we just need to know that there's basically probably three rules we need to memorize. If we're going to go clockwise 90 degrees, well, our x, whatever number this is, it goes to the back and changes signs. The y value doesn't change signs, but it comes to the front. For example, let's say this first coordinate was 1, 3. When I turn this figure across the around the origin, 90 degrees clockwise, that X is going to move to the back and become the opposite, and the Y is going to come to the front and stay the same number. Okay, so that's one of the rules we need to know. All right, counterclockwise, well, the X goes to the back and stays the same sign. The Y comes to the front and turns into the opposite sign. So both of the directions, they're changing positions, but going, you got to pay attention to which sign changes. So I'm going to write this down real quick so that when we're doing these problems, I'll remember 90 degrees clockwise. And you should probably write them down too, because it's easier if you can see it in front of you. And then for counterclockwise, they still change positions, but this time the Y changes. Counterclockwise, and then we really only need the other one, which is a 180-degree rotation. They stay in the same position, but they both change signs. 180. All right, now how are these going to help us? Well, let's look at this first figure. So we have point C is at 1, 4, and we're going to go 90 degrees clockwise. Well, I just wrote down the rule, and the rule for clockwise is that our two numbers change positions, but for clockwise, the X changes signs. So we're going to take that 1, we're going to move it to the back, and it becomes negative. The 4 comes to the front, and it stays a positive. So that C, when we turn this thing 90 degrees, it's going to come down here to 4, -1, right there. It's like we're turning that figure. We're turning that figure around the origin. All right, let's see what else. What's the next point they give us? They give us P is at -3, 4. So the 3 goes to the back and turns positive, and that 4 just jumps to the front. So we're going to turn this to 4, 3 right there. 1, 2, 1, 2, 3, 4, 1, 2, 3. Oh, I almost missed it. There's P prime. All right, what about one of the other corners? -1, 1, so T is at -1, 1, so we're going to move this -1 to the back. It becomes positive. This Y value comes to the front and stays the same. So T prime is at 1, 1. So this is T prime. And then finally U prime, -3, 0, so that -3 jumps to the back and becomes positive, and our Y comes to the front. So don't go right or left, go up 3, 1, 2, 3. And there is our U prime. So we're going to connect the dots. And we have a congruent figure. We've just laid it over on its side. We've turned it. Okay, so it should be the same shape, same size. So 270 counterclockwise is the same thing as 90 degrees clockwise. So we just practiced that one. And then you have the rules for counterclockwise, all right? And then 180 is you're going to turn it completely upside down. I'm trying to find one with 180. Here's one. All right, so if we turn that thing 180 degrees, it's going to look just like that, except that Q is going to be way down here, right there, right? It's going to turn upside down. So this becomes -2, +4. So A becomes -2, +1, 2, 3, 4. There's A prime. Our next coordinate is 5, -4. So it becomes -5, +4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's H prime. And then we have 1, 0. That becomes -1, 0. So there's P prime, and then the last one is 4, 1 becomes -4, -1. 1, 2, 3, 4, -1. So there's our Q right there, Q prime. So we just flipped it upside down, turned it, and there we go. All right, so that's a lot of stuff quickly, but let's look at a few of your example problems that you have to do for Wednesday. Let me stop sharing this for a second. All right, so let me pull up your translations. Practice problems. Let me share this screen with you. All right, it says line segment CD has a length of 3 units. It is translated 2 units to the right on a coordinate plane to obtain the line segment C prime D prime. What is the length of C prime D prime? Well, if you translate, what happens? Does it change sizes? No, it doesn't. It's still going to be 2 units. All right, this figure shows a pair of parallel lines. The line segments are translated 2 units to the left to form A prime B prime and C prime D prime. Which statement describes A prime B prime and C prime D prime? Well, if we go 2 units to the left, we're going to go 1, 2. So A prime is at 0, 1. Are they ever going to intersect? If they don't intersect now, these say they're going to be intersecting. Is that true? No. Are they any further apart than they are right now if we translate both lines? No. So letter B right here says line segments A prime, B prime, and C prime, D prime do not intersect and are the same distance apart as the first 2 lines. That makes sense, doesn't it? All right, you have a polygon and the sides are 5 units. You're going to slide the whole thing 5 units right and 4 units down. If the original angle of measure M, which is the second letter, was 50 degrees, what's the measure of angle M prime? So guys, basically they want you to know that everything's going to stay the same. Same size, same shape, same angles. So if the first M is 50 degrees, the second M prime has got to be 50 degrees. All right, so it wants you to figure out how this thing's been slid. So remember, the purple one's the original because it doesn't have the prime marks. So we had to go right and up, right and up. So I'm going to let you figure out that one by yourself. And the same thing here. They want you to figure out, figure out which one has been slid. It hasn't been rotated. It hasn't been reflected. It's been slid. So it's in the same position, okay? So think about that when you answer that last one. All right, and then the other one has to do with rotations and reflections. I gave you a video on all this as well. And so you're gonna have problems, you're gonna have questions that are very similar. So I think you guys are gonna do very good on those types of problems, okay? All right, you guys, I hope everyone has a great week. If you have any questions or if you need me, let me know and I will help you. Have a good day.